The entire universe is composed of matter and energy. Whatever we see or we feel is either matter or energy. Hello everyone, welcome to Amader school, and this is Fahad from Bangladesh. And this is the very first lecture of English versions that I am trying to upload in all the classes of physics, chemistry and biology. Based on the chapters inside the topic, I shall be trying my level best to upload regularly to you. So those students who are reading on English versions, for you, I'll try my level best to upload physics, chemistry and biology. The number of chapters, I'm trying to make a plan divided into some specific topics per class, and then I'll try to upload these classes regularly. And today I shall upload the classes of states of matter, SSC Physics Chapter 2. And there are some topics that can be considered to understand this chapter very deeply. And these are the matters. As you know that this is the chapter of states of matter, we need to understand first what is matter. So before understanding that, you see the topics that should be considered in this chapter is matter, states of matter, changes in matter, intermolecular force, and as well as we'll study intermolecular attractions, classifications of matter, kinetic theory of particles, diffusion and effusion. This is very well known topics of this chapter. And also we need to understand the melting point and the boiling point. And last of all, this is a very important topic to understand, that boiling curve and heating curve and cooling curve. This curve represents a line that shows the relations between the temperature and the time and changes of matter. So in this class, as it is a part 1, states of matter, I shall explain to 1.5, and rest of the classes I will explain in part 2. So what is matter? If this is the questions, you must think 3 things: that a matter has a mass, a matter which definitely occupies some space, and a matter which has the inertia of rest and motion. So in case of considering matter, in case of defining matter, we need to understand 3 factors. Number 1, what is matter? It must have a mass. It definitely occupies space, and then it has some inertia of rest and motion. So what is matter? In case of defining matter, you need to consider these 3 factors. And then in case of states of matter, we all know that matter has solid, liquid and gaseous state. So what is solid, liquid and gaseous states of a matter? To understand that, we need to think about the intermolecular force. Very common example of changing substance, changing the states of matter, we consider ice, water and vapor. So what is about the ice, water and vapor? Suppose in case of changes in matter, we know that when the states change, if it is a question when the states of matter change, we know that supply of heat into the matter, it creates the changes of states. Like in ice, when we heat it down, it will be water, again heating down, it will be vapor, and then when it be cooling down, it will again come to water, and then reversely, when water is cooling down, it will be ice. So in case of understanding matter, in case of understanding the state, the changes of matter, we know that the intermolecular force inside the particles, it definitely changes when heat is being supplied. So states of matter 3: solid, liquid and gaseous. So understanding these 3 things, we must know that what is the difference between these 3 states of matter. In case of solid and in case of liquid, and in case of gaseous, we can see that if the topic is definite size and shape, mass, size, shape, intermolecular force. If we see the factor is here mass, the amount of mass in case of solid, liquid and gases, it will remain same. Suppose if 1 kilogram of ice is being turned into 1 kilogram of water, 1 kilogram of gases or vapor, it will remain same the mass. So in case of solid, liquid and gases exchange of matter, the mass will remain same. But in case of size, in solid states of matter, the size would be definite. It would be a definite size and also a shape. But in case of liquid, there should not be any definite size or any definite shape. Suppose in case of water, if we pour down the water in any type of container, it will keep that shape. So in case of liquid, there is no shape, but the mass of the liquid, the mass of the specific liquid would remain same. In case of gas, in case of gaseous state, there is no specific definite size and shape, but the mass of the gaseous substance would remain same. So in case of intermolecular force, that is very important to understand the kinetic theory of particles. In case of solid, the particles remain very close with each other and hence they stick together. So intermolecular force in between the particles is so high. But in case of liquid, the particles inside the liquid remain little bit space in between them. So as we know that in case of solid, liquid and gaseous substance, the particles is always vibrating. But when it's get heat, the energy allows particles to make it more vibrations, and that more vibrations allows these particles turns into solid to liquid and then again liquid to gaseous substance. So when it's just have more energy through the supplying heat, it will be like a gaseous substance, and the intermolecular energy would be so less, and that is why the entire gaseous substance would be free from each other. So considering the intermolecular space is much lower in case of solid, a little bit space in liquid and more space in gaseous substance. So if we consider the states of matter, we will find solid, liquid and gas. And to understand matter, we must know the classification of matter. As far I know that you already studied the classifications of a matter, we know that we can divide matter into two different specific compositions. Like if we see this is matter, number one, it would be mixture. It would be mixture of two or more than two different substances, and this is pure substance. This is pure substance. So based on the composition, we can divide matter into two different steps, like number one mixture and number two is pure substance. In case of mixture, we will find two different type of mixtures. Number one, heterogeneous mixture. Number two is homogeneous mixture. So what is heterogeneous and what is homogeneous? I am sure that by this time you know what is hetero and homo. Homo means similar type of, hetero means different type of. So as we know that by the based of composition of matter is divided into two different parts, is mixture and pure substance. Mixture is two different categories, heterogeneous and homogeneous. In case of pure substance, we found a pure substance divided into two different parts. Number one, elements, and number two is compounds. So pure substance divided into two different topics, elements and compounds. Elements is further divided into two different things, which is metal and another is non-metal. So to understand the classification of matter, this is very easy, I know for you, but mixture, like if we mix sands and sugars together, that we can easily identify that two different particles is here, and the ratio of the mixture particles are not same. So the heterogeneous mixture, the example is sand and sugar. But in case of homogeneous mixture, you see the salt water, you see the ocean water. If we collect amount of ocean water, we see the whole water is salty, and the ratio of salt and water is purely distributed. And also, if we take 1 glass of water and pour some 1 tablespoon sugar and then mix it up, it would be a homogeneous mixture, because altogether the entire mixture has a normal distribution of sugar. So this is the homogeneous mixture example. In case of pure substance, as we see the elements and compounds. In case of compounds, you see that compounds has, if we do a chemical analysis of compounds, we will find more elements. In case of elements, that if you do the chemical analysis of elements, you will never find anything different properties substance. Like elements is metal and non-metal. As you know, the example of metal is like you see iron, copper, zinc, whatever you see, zinc, copper, iron, silver, mercury. So these are the example of metal. In case of non-metal, you see, we know that carbon, nitrogen, phosphorus, sulfur, lots of things. So these are the example of non-metal. And in case of compounds, we see like water is a compounds, because there are two different elements like hydrogen and oxygen. In case of carbon dioxide, we also know there are two different elements, which is carbon and oxygen. So these are the example of compounds, which has more elements together. So this is the classification of matter. And also, if you see, the 1.4 topics is intermolecular forces. If the question is what is intermolecular forces, that force which is the main reason that the states creates their own existence, like this is solid, this is liquid and this is water, because the intermolecular force, the intermolecular attractions is much higher in case of solid, and comparatively is less in case of liquid, and comparatively more or less in case of gaseous substance. So the intermolecular force is the reason of physical existence of matter. And in case of classifications of matter, this is the classifications. And the kinetic theory of particles is, what is the meaning of kinetic theory? That means kinetic means the particles inside matter that gets the energy to vibrate more, and then it changes their states. Like when in case of ice, why we use ice? Because ice is very normal to us, like ice. If we heat down ice, then it would be water. In some space, it would be water. When we usually know that ice is formed of solid states of water in 0 degree Celsius. In 0 degree Celsius. And when it just turns on the temperature, it becomes water. But when we put 100 degrees Celsius into the water, it would be another state which is dim. So it means that a specific pressure, the temperature which turns the solid into water, it's called melting point, and the temperature which alters liquid to gaseous substance, it is the boiling point. We usually know the melting point of ice is 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. If we take sodium chloride, which is table salt, the boiling point of sodium chloride is 801 degrees Celsius. And in case of water, the boiling point, in case of sodium chloride, the boiling point is 1465 degrees Celsius. If we ask why this is so huge, because of the intermolecular force. And this is the changes of different types of matter. Like this is ice, this is also solid, this is sodium chloride, this is also solid in room temperature, but in ice in 0 degrees Celsius, before that it's ice, but the melting point of ice is 0, but melting point of sodium chloride is 801 degrees Celsius, as because the molecules of sodium chloride remains very close and the intermolecular force in between them is so high. So that is why much more energy is needed to break down the energy, to break down the intermolecular attractions. That is why the melting point and the boiling point differs from state to state, from matter to matter. Like methane, this is a gaseous substance. This is gaseous substance. If we see, the melting point is minus 183 degrees Celsius and the boiling point is minus 162 degrees Celsius. If you study well in case of temperature, why it's so varied? Because of the states of matter. Here the methane, the normal states of methane is gaseous. That is why the boiling point is minus 183 degrees Celsius. It's gaseous substance, but it's solid substance. Hence, the boiling point and the melting points varies based on the situations, based on the pressures. Like here, we see the melting point and boiling point. The definition of boiling point and melting point is that the word melting point actually expresses the temperature. And we know that unit of temperature is degrees Celsius. We will study on physics that the temperature unit like degrees Celsius, Kelvin and degree Fahrenheit. So to understand this chapter, I just only explain the very first and primary things in case of part 1, the states of matter. In part 2, I shall upload a class describing the heating and cooling curve, and also these two important parts, diffusion and effusion. So if I wrap up the class and to make it summarizations, you need to know that what is matter? The matter which has a mass, which occupies space and which has inertia of rest and motion. In case of classification of matter, we got two different parts. Number 1, mixture, which is heterogeneous and homogeneous. In case of pure substance, we'll find elements and compounds. So compounds are like all the combinations of all other metals and non-metals and all other things. But the pure elements is no metal and non-metal. So we will describe things later on, what is actually metal, what is non-metal, what is compounds, what is mixture, and lots of things. From the very beginning of this class, you just need to know some definition of boiling point, definition of melting point, definition of matter, the properties of matter, the classifications of matter, the reason of changing states of matter. And also, one thing I should inform you that in case of changes of matter, you also found two different changes. Number 1, physical change. Number 2, chemical change. What is physical change? Suppose this is a very primary basic, that changes are two different types, physical and chemical. In case of physical change, only the shape and the physical existence of a matter can change, but no new elements or no new matter will produce. But in case of chemical change, new properties of new substance will produce. Suppose if I rub an iron metal with a magnet, gently rubbing of a iron metal with the magnet, it will be a magnet, for instance, and it will attract some iron particles to each other, but the iron properties will never change. Iron creates a new properties by rubbing a magnet on it, but it will not create any new properties. After removing this magnet, it will remain same. So this is the example of physical change. Also, you know very commonly that I explained before that if we give heat to ice, it will be water, and then after again further heating, it will create vapor or steam. It is the example of physical change, because water remains water, the molecules remains the same, but the states are changing. So it's the change of physical change. But in case of chemical change, what is the chemical change example? Like, for instance, if you see the burning candle is a pure example of understanding the chemical change. If you see that when you burn a candle, some portions melted in between and down, this is part of physical change. But this fire, it's actually example of hydrocarbon. When hydrocarbon is having reactions with oxygen, and that means oxidation is happening, then it produces carbon dioxide and water. The properties of carbon dioxide and water are not same of this candle, which is actually a hydrocarbon. So the burning of a candle has two different type of changes, physical change and chemical change. So when it melted down, it is the example of physical change, but the burn, which actually creates the carbon dioxide and water, is the changes, the example of chemical changes. Like when iron is resting for the long time with moisturizing water, then what will create? The iron with water and oxygen will create rust. So this rust is the example of chemical changes. So what is actually chemical change? Which change allows more or different type of properties, different type of substance from the previous substance is called chemical changes. But in case of physical change, it only allows the changes of size and shape, or also the physical existence, but not the properties of molecules. So the properties of molecules will remain same in case of physical changes, not in chemical changes. And of course, you know that in our plants every moment is going the photosynthesis. So in photosynthesis, water and carbon dioxide is reacting each other and producing glucose. The properties of glucose and properties of carbon dioxide and water are not same. So this is actually the chemical changes. If we freeze down a tub of water into the freeze and it will be ice, this is the part of physical change. This is the example of physical change. So very primarily, I just only explain some part of states of matter. In part 2, I shall explain more about the changes of matter and also the heating and cooling curve, which is very important. So those you are studying, please try to understand things and think what you are reading. Think about that you are reading, you visualize the scenario, and then you will never forget your study. You will definitely love your study. So see you in the next class. I shall try my level best to come up with new classes every day. Thank you so very much. Bye.